Another recording. Okay, hello dear students. So today's lecture will be about functions and how we can use it in Python, understanding what's going on under the hood in the interpreter. So I want to share my screen. Let's can you see the screen?
Yes, we can.
Okay, thank you. So let's name this lecture as functions and namespaces. And let's start with understanding how we control our workflow inside the programming language. So as you know, the programming languages and computer science is some kind of old science, and from the time of John von Neumann and other pioneers of that area, nothing changes in the core of the workflow. So we have a workflow that look like this. We have some command that goes after another command. We have different structures to control this workflow. We can use conditioning and switch between different branches of the workflow and use another commands there. We can use cycles that use condition to return us back in the workflow, and by some condition goes forward. And using only these types of control of our workflow, we can really write everything in the world. So every program that is possible can be written only using conditional statements and cycles. But the thing is that we want to write programs effectively. We want to write programs in such way that other people can understand us and can modify our programs. And there are two paradigms of working with programming code. So in computer science and in other I don't know how to express it. Maybe some kind of Western sciences, they like a lot of abbreviations. So they have two abbreviations for the different styles of programming. So we can use dry programming or wet programming. What do they mean? So dry is the concept or paradigm that we do not repeat ourselves. In the dry abbreviation, this is yourself. Do not repeat yourself. Yes, of course, we can use a lot of lines of code here. We use branching and a lot of lines of code here, and the program will work in this case. Of course, it will work because once again, using conditioning and cycles, we can write whatever we want. But a lot of code will be duplicated, and this is bad for the reading, for the modification of the code, and to understand for you what's going on in your code. So if you want to dry your code, just please try to not repeat yourself. And the opposite way to write a program, like I described already is wet. Wet is we enjoy typing. I think you have heard a lot of jokes about some strange code from low-cost programmers that have a payment for each line in the code and they use very strange construction, the millions and millions lines of code that can be reduced using the dry principle. So from here, we can start to talk about functions, but I want not, I do not want to go to the Python for now. Just let us think about function itself like an abstraction, what it is. The word of function, what does it mean in the computer science? So you have your comments. 1, 2, and 3. And you want to use it together in different places of your code. You can combine them in the one code block. Actually, in Python, we have such a definition code blocks, but now I just understand this code block, just a sequence of the commands that goes one after another. So the first invention in computer science was procedure or routine. This is just a code block consists of the sequence of commands. So this code block consists of commands that have a name. And we can call those commands in this particular order, just calling the procedural name in different ways. So in Python, we use brackets to call some callable objects. But what's the difference between procedure and function? In procedure, we just interested in the execution of this command line by line. We do not expect that procedure returns us some value. So we just execute procedure to execute each command line by line. So we just reduce the amount of code that we have in our program. But using the function, we do the same thing. We execute commands line by line that are inside the body of the function. We call it the body. But we expect that function return us some value. So each function have two properties. In overall, like a routine function have two properties. So function do something inside body, because here we can have any command or another functions, for example. So this is a legit computational flow just inside the function. So function do something and return some value. This is a core difference between the function and procedure, because procedure only do something. It's not return value. In the Python, we have no procedures. We have only function. But of course, you can ask the question, why we have such function as, for example, print. So what we want from print, we use some argument inside the print function, and we just want that function print do something. Particularly, we want a function print to print our argument into the standard output. But as I say, in the Python, we have no procedures. Every function returns something back. So we can use, for example, assignment to the x equal print something, and it will return none. So all functions that behave like procedures in the Python return non-object. Okay, let's think more Pythonic how it works. We have assumed that we work not in interactive regime with the interpreter, but with program files. Assume that we have our file with our program. Inside the Python, it's called main. And this is our workflow here that is written in the Python language. This is just our lines of code. And somewhere here, we define function foo that do something. And here we call function foo. We will talk about the syntax of defining and calling, but for now, I want to show how it works inside a Python interpreter. So as you know, workflow goes from the top to the bottom, line by line. And here we have a function execution line. So we execute the function foo that was defined somewhere before. And what's going on? It creates a new flow with a code block from function foo. And here we have some code that was defined here. And maybe it has another function called, I don't know, bar, for example. So it calls bar function, and bar can be defined here or here. It's not so important. So it's once again, it opens a new workflow with code inside function bar. But after all commands from the function executed, it must return some value. So, for example, it counts some value val here, and it returns its value val here. Where should function bar return its value? It really depends on the call of the function. So it will return its value right here where the function was called. But how computer, and particularly Python interpreter, knows where is the place where we want to return our workflow, where we want to proceed with workflow. So after return, we proceed from here. So the workflow is like this. And the thing is, when we call function in the Python model, we create a special, I do not know how to call them, not to disturb you. Let's name them objects, but it's not like our usual objects, what we talked later about. So we create a special objects that have all of the information that we need to return to the needed position, and we store all of them in the calling stack or call stack. Please tell me, are you familiar with the conception of the stack like a structure? I think no.
No.
Okay. Okay. So you can, oh, okay. This is a glass of water, but please, you can think about it like a glass with a cocktail inside with different layers. So the main feature of the stack is that we put something inside one by one. So this was 1, 2, and 3 objects. And we can take out only elements from the top. So we can take out in such order as 3, 2, and 1. So first in, last out. This is another abbreviation that is for stack data structure. So the object that first goes into the stack goes out in the last position. It's really easy to understand it like a pile of the books or like a glass of the layers of some water or grain, I don't know. So we have layers and we can get out only the bottom, only top layers. So let's talk about calling stack. Calling stack is just a usual stack where we store function objects. Okay, I will delete all of this. So once again, we have our calling stack. First of all, we create a new object on the stack when we execute function foo. So here we have function foo with address of return. So it knows where to return its returning value when it finished execution of itself. After that, we call function bar from function foo. So we add to the stack function bar, and it has return address. And so on. If we have here some function f2, we call it, and it will be added to the top of the stack. And when function f2 finished its execution, it returns to the function bar here, it returns its value, and we get rid of this. And now bar is on the top of the stack. After that bar is finished, we return value to the foo. We get rid of that. And this is the concept of stack call. We can illustrate the stack call using our error description in the Python. So if you work with Python, not only with my test system on Stepik, you can see the output of the error message system. So it shows you a stack of calling. So let's create some test file. let's create function that execute function bar, and here we must have function bar that execute function f2, and here we must have function f2, and I intentionally want to do a mistake here, for example, zero division. Let's assume that inside function f2 we want x to be 2 divided by 0, so it's impossible and it will raise an error. And after that I just call function foo. So Python, I forgot who call py. Okay. So what we have in the traceback, what does it mean traceback? So this is a trace by the function stack, function call stack. Without this process, this stack exists because we not finished the execution of function f2. We have error here. So the traceback calls us that error was in our original file in line 10. Okay, I can one minute. Turn on, how to turn on line numbers. I forgot. Okay. So we have line numbers, and what we have in traceback. In our file foo_call.py, in line 10, in module. This module means main here. So this is called module because we run our Python interpreter using our file. Our module will be our file. So in module, in line 10, we have a function called foo. Yes, we have here. So what next? Next, in line 8, in foo, we have a call of bar. So yes, a function foo calls the function bar. Next, in line 5, in bar, we have call of function f2. Yes, we have this call. And the error was raised inside function f2 here. And in the line x equal 2 divided by 0. And of course, it is division by 0 that is not possible in Python. So it gives the error system gives you a full traceback of function calling stack, and you can understand in what position inside your workflow the error was raised. So you can trace your error by function calls. So this is the explanation of what error messaging system wants to tell you when it gives you a lot of lines of text. It just gives you a function call stack to you to understand how it was executed before the error was raised. Okay, so please, today I really appreciate your questions because it's very important thing. If you have some.
That's clear. Thank you.
Okay, let's go next. I will try to show you what does it mean asynchronous call. So it is important to, after that, define the synchronous call. So assume that you have your main module here. This asterisk is just the beginning of the execution. After that, you find the line with execution of function foo. So it means that we go to the function foo workflow for function foo commands and start to execute them. But we can think what the main workflow, what main thread. So there is such a definition as execution threading. So here in calling the function foo, we switch our not switch, we just branch our execution to another thread, not thread in the case of the processors, but on the execution thread. So now we execute function foo commands, but maybe we want to execute function foo commands and do not stop main commands from running. And we can do it actually inside Python 2, and we call it asynchronous asynchronous call or execution. I want, I think, to imagine some example. Maybe the interesting example is from chats. So like Telegram, for example, there is a thread that listen to the port listening. I mean network port. So it's listen port, and it understands that some new information come to the port, and it's called some function to process this information. For example, you have a new message, and it's called function process proc, for example, and it goes with processing of the message. But the listening function stay working. It proceed listen of the port. Maybe it's a bad example because it can be done using different approach like events and other things. But the main goal is to understand that one thread of execution can stay working while we create a new thread of execution. And of course, we want to merge those threads after one finished. So we assume that how function foo will finish its work and what to return to the function foo, to the main function. And the situation in asynchronous call can be really different. So we can be ready to No, it's not like this. We can be ready to the function foo return and waiting for the results. We can be after this return. So we just store here some variable and process this variable here. So that's why it's called asynchronous, because usually it's not the same time when the function foo return its value and when we process the result of the function foo execution. Okay, we will not work with asynchronous functions because this is a much harder things in programming. It you can think, and I think you heard a lot that asynchronous calls use it to parallel something, but it's just a part of usage of asynchronous calls. So the main goal we use them is to branch in our execution threads. So assume that you have broken your TV set at your home. U is a main function, and TV master is a foo function. So you call the TV master, and TV master start to work with your TV set, and during this you work with your homeworks in Python, for example, and you not waiting him to finish his work. You can process and assess his work and give him money after he finished. So this is asynchronous trading. And what we will consider is synchronous trading. Look, this is a main module or main function, and we call function foo. So this is a call. This is a starting of function execution. And in synchronous execution, the thread that called the function waiting till the function finished and return its value. So here we have no execution of the main thread. We just stop and waiting of the execution of function foo. And all the functions that you have used are synchronous, and we work in such particular scheme. So we waiting of the function to return some value. Okay, why I wanted to show you how we can call function using the threading system. The thing is that each time we have this asterisk, we will create a new namespace. So assume such situation. We have module main. It executes function foo. Like in previous example, it executes function bar. And it returns to the main thread. So here we have 1, 2, and 3 asterisks. And each this asterisk, each this branching will create a new namespace. What does it mean? So you can remember, one moment, our module, our data module. So we talked that we have names and objects inside Python. So this is a half of the truth. The names is not the one huge space with all of the names. It is divided by the execution of the functions. It's divided to separated and nested namespaces. So how it looks like? Maybe I want to use Python together. So let's write something. First of all, we have a global namespace. No, that's not true, because look here, we can use function print, and function print is the what is the execution of the function. So print and brackets means that please execute the object that called me print. So somewhere in Python we already have name print, and the interpreter knows that the object that has name print can be executed. So all of these names of the functions, such as print, len, str, input, they are stored in the into the biggest namespace called built-in. Built-in. So it's the largest namespace in the Python. It stores all the functions that already are in the Python interpreter by default. After that, we have our, just to make it more nice, I want to delete this. Oh. Right, built-in here. After built-in, we have another huge workspace called global. So here we have, for example, print name, not a function, just name print, because we here have names. And print is connected with some object here, but I will not draw it here because it will be a mess. So print, int, input, a lot of different names that already are in the Python. So what is global namespace? Global is our namespace. We create it in our Python file. So when I create such string like x equal 1 inside just our module, inside our Python file, it will create a name x here that will be connected with integer object 1. So in global namespace, we will have x. And I just remind you that we are still here. So here we have a x equal 1 command. this is just the first asterisk. It's mean create global namespace. Okay. Maybe I want to create some another variables like y equal 2. It will be the same. Okay, and after that, I want to define function foo. And I want to create, not to create, but to have arguments inside this function that calls x, for example. And this function will return I don't know. Okay, x plus 1, for example. And after that, I want to execute this function. So it was a definition, and this is an execution. So when we have execution, we have another asterisk in our threading execution, and it will create a new namespace of the function foo. And we have an argument x here, and it will be an name inside the function foo namespace. Actually, I have called function foo not correct because we must use argument here. And for example, I want to use y here. What it will be? So we send inside a function not a name y. So not y goes here. It sent the link of the y. So this one. And x will be linked to the same object. So we send this link by name y inside the name x inside the foo namespace. And of course, function will return to the global. For example, not just this useless call. For example, z equal the result of the function. So we will have x plus 1 here. That will be a new object 3 with integer type, and it will be returned to the z. So we return once again the link to the object. So z will link to the object 3. And after function finished execution, the namespace will be deleted. So all names that are in the namespace will be deleted. And of course, all the links. And for example, if we call function foo not with y, but with just okay. So assume that we have no y inside our global namespace, and we just call function foo like z equal to the foo with argument 2. It once again will create a new namespace of foo, and inner argument x will be linked to the object 2. And when we return x plus 1, it will be connected with 3, and z will be connected with 3 as an output of the function foo. And when we finish the function execution, the namespace will be deleted and all links will be deleted. So the garbage collector will delete the object 2 in that case. Okay, so this is how it's work, and now let's think about how functions search to the variables. There is such paradigm like LegB, another abbreviation. It means the order of search inside a function. I will show you an example after definition of LegB. So it means at first we look at local namespace. Local first. Next we use enclosed. Next we use global. And the last one is built-in. At first I want to draw. So once again, we have built-in namespace. We have global namespace. We have function f1 that calls function f2. So assume that we have function f2. Inside of that, we want some name x, where we will try to find name x. First of all, please use local. So function f2 will try to find name x here. If it cannot, if there are no such a name inside f2 namespace, it will try to search inside the enclosed namespace. The enclosed is the function above, or in terms of stack. So this is f2, this is f1. So at the bottom level of this calling stack. So here we have global, but I'm not sure that it's right to show it like this in stack. Maybe we can think about this or like this, but that's all, because your traceback in the error messaging system return this description: global function f1, function f2. So enclosed. If in enclosed namespace there are no name x, it will search in global, and after that in built-in. And if there are no such name in all of these namespaces, it will raise an error. So let's try to show it on the example. I need two functions. So first of all, we now are in the global space. let's create name x equal global. After that, let's define function f1 that has name x equals string f1 namespace, and it will call function f2, and function f2 will print name x, and it will have name x here. F2 name space. And in our program, we want to execute F1. So I just repeat this function call. Once again, we have main module. We call F1. We call F2. So we will have built-in namespace, global namespace, F1 namespace, and F2 namespace. Okay, let's execute it. And if you understand, we assume that we will have in the function to call, we will have F2 namespace, because function F2 wants to print some object that has name x, where it can found it inside its own namespace here, and it is F2 namespace. So let's try. Yes, it's F2 namespace. Let's delete it from F2 namespace. So I just use a comment here. And now it shows global. Why so?
Because the first string in your code.
Okay, but the function call was F1 first, then a new name inside F1 namespace called name x, and after that call of the F2 function. Maybe some typo somewhere. Seems no. Okay, it must work in another way. So once again, we have namex here. It is F1, F2 namespace. Okay. If we comment this, it must be in enclosed namespace. Enclosed namespace is F1. So we must use this name with this object. Why it's not working? Let's
Maybe
Google.
in this case, we should define the function f2 in body of f1. No?
Yes, 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 absolutely. Thank you. The thing is that the definition of the function f2 was inside the global namespace. Okay, okay, I forgot that definition is important too, not only the execution. So in Python, we can define the function inside another function. So if we do it here, yes, we will have F1 namespace. So about enclosed, I was wrong. It's not about calling function inside other function. It's about definition. So it will, where is leg B? So enclosed means that it will search of the name inside the function in what it was defined. Okay. So function F1 enclose function F2 here because it is defined inside. Okay, and the last example, if we will have no such name like name X, all other things are the same. And now we have name error. So if you see such types of the error, name X is not defined, it means that function F2 tried to find name X inside its own namespace, enclosed namespace, global namespace, built-in namespace, and can't do it. So this name is not exist in our data model. And we have a name error. So how many time I have? Okay, let's go to the formal syntax things about definitions and calling functions. And in this part, I have only 20 minutes. I want to show you another way to use Python. So maybe some of you are familiar with this. We have another version of the interactive work with the Python called IPython, and such programs that like IPython notebooks. So Jupyter Notebook, Jupyter Lab, and I want to show you Google Colab because it's a really useful instrument and it's free. So we have to find Google Colab. Oh, some typos. So Google Colab is a web interface to the I want to create new notebook. This is an interface, web interface to the remote server on the Google site that allows you to use their computational resources to run your Python code, and the resources are really good. They have GPU cards, they have cool processors, and all of these resources are free for you, and you can use it, I think, up to 12 hours. And how it works. So I think you will see the light theme. And not to disturb you, maybe I want to change it. Adaptive. So I think you will see such a picture if you open it first time. This is a usual Python notebook. It works with the abstraction around the code called chunks. So these lines here, these bars, are chunks. We can, why it's so slow? So we can run, we can type and run code here. For example, like in usual Python, we can use it like calculator. We can define functions here. And after that, execute functions. So it's look like interactive usage of the command line tool, but all of the results stay here and you can edit the previous thing. So I can edit function foo to use 2 arguments and return the sum of these arguments. And after that, call it with different numbers. So this is a very powerful instrument to your data analysis and visualization of your data. So when you work in lab or with your homeworks in different courses inside our master program, it's really helpful to see what's going on with your data. And here you can visualize, or using Matplotlib, for example, you can visualize your data, plotting some distributions and other things. I think you have some classes with statistics. I forgot actually about your curriculum. So Jupyter Notebook and Google Colab are very, very useful things. I think I can send you different links to video or text description how to use them. So Google Colab is an internet resource, and Jupyter Notebook can be installed on your system, so you can run it without internet. Okay, let's go to the formal syntax definition of the functions. So first of all, we already know that we use the word, I want to do it more large. So we use word def for the definition of the function, and after that, function name. The word pass for do nothing here. Please pay attention to the function name. So there are conventions in PEP 8 how to call functions, how to use your function names to be understandable by other programmers. And by syntax, it can start with a number. So this is not a legit function name, but it can be start from underscore in Python. So please read PEP 8 to follow the convention, how we can create beautiful names for functions, and please be understandable. Here in function name, we prefer to use some verbs. For example, calculate sum or get weight, and count statistics, and so on. So the function name is some verb. So Python, please do something inside. Okay. So we have function foo, and this is the most interesting part, the function arguments. Arguments are names that is linked to the objects that we want to be sent inside the function body. So code here, we called function body. And there are a lot of ways to send arguments inside the function. Let's think about the, I don't know how to call it in English. So we have such abstraction as bicycle, when the good implementation of the function is already exist, but we want to create our own, and sometimes we call it inventing bicycle once again. So such a bicycle will be a function min, because we already have min function in Python. But assume that we want to reinvent the bicycle and write our min function. So let's start with two arguments, x and y. We want to return the minimum of them. So if x less than y, please return y. Else return y. Yes, it's minimum. So minimum with 3 arguments will not work. Why? Because we redefined our built-in function min. And this is an error that was created because we do not respect the built-in names. A lot of syntax coloring system, they can, I think, colored the, for example, dir. No, in Google we can't color the built-in functions. Okay, but in IDEs, for example, in PyCharm, the built-in functions will be colored. And please do not use such words inside your program. For example, sum is the built-in function, and how it works. We send some iterable inside. Oh, iterable must look like this. And it returned the sum of this. But if we create our own name for the variable sum and add 2 numbers there, we can't use sum in the future because we redefined the name sum. It will be an error. It's just an int object 3. So here we redefined our min function, and this is just bicycle our 2 variables x and y. The previous built-in function min can work with arbitrary number of arguments. But let's look in the function call. So we have 1 and 2, and it will return 1. So we called these things formal arguments. The formal arguments are the names inside the function definition. And these things we can call actual arguments, or so I forgot how it's in English. fact arguments, or so this are the actual arguments that will be sent inside the function. The difference is that here we define names and the places for the arguments, and here we defined the values of the arguments. Okay. Here we have names. Here we have just values with some position, and we know that this position will be for X and this will be for Y, but we can change them. We can say, please Y be equal 1 and X please be equal 2. So the result is the same, but it will send inside. I can add inside function some string f x so just to understand what arguments we have inside. Without this, we have x equal 1, y equal 2, and the result is 1. And we can change the order of the arguments inside using the explicit names. So we call such arguments positional arguments. Let's think about the number of positional arguments. So assume that function min is for any number of objects. So it is beautiful that it can solve what is less 1 or 2, but maybe we want to find the minimal element inside the list, for example. So how we can implement this thing? We must use positional arguments like an sequence of objects. So I want to rewrite this. Of course, we can use here arg and send some iterable here. 1, 2, 3, 4, and 4 element in arg min equal. There is a special float number called inf. This is the most larger number in floating numbers. So if you read the float standard, you will see the special objects inf and minus inf, and they represent the minus infinity and infinity. So this is the smallest number in the real numbers and the largest number in the real numbers. And we can use it in our addition, our current min value. So for element in arg, if element less than current min, let current min be element. And after that, please return current minimum. So it must return as 1. Have 2 brackets. Yes, it works. It returns as 1. But maybe we do not want to use here an iterable object. We just want to sequence our numbers using comma like this. And this can be any number of arguments. How to do with this? we can use unpacking of arguments, of positional arguments using asterisk, like an unpacking of iterable objects. And it will work, I think, the same. Yes. So let's create, for example, -45 here. Yes, it works. So this is a standard syntax to use for positional arguments inside the function. If you have an arbitrary number of arguments that you want to send inside the function, you can unpack them using asterisk and args. I forgot args. We prefer to use asterisk args as a standard notation for the arbitrary number of positional arguments. Okay. We have special arguments that have a default value. So for example, in min function, we want to have a bottom border for our min. So your minimum can't be less than bottom border. For example, we will call it border BB, okay? And using equal sign, we can create a default value for the argument. So we have positional arguments and named argument with the default value. So we can use it inside function call. So if element less than current minimum and BB more or equal. Yes. So it must return the minimum before the bottom border. It must be 1. No, it not works. Why -45? BB is by default 0. 0. Oh, less or equal. Of course. So now we have a named argument with default value that represent our bottom border for the numbers. We can use it with name inside function call. And for example, let BB is equal to 3. Okay, we have bottom border with 3, and the minimum in such case will be a 3. There is another type of arguments. I think it is slightly harder for today to talk about them. This is a keyword arguments, and they can be unpacked like this using 2 asterisks. I haven't talked with you about dictionary unpacking. We talk about dictionary not a lot, but assume we have dictionary like this. A key is mapped to the 1, key B is mapped to the 2, key C is mapped to the 3. This is our dictionary. And please do not use dict for the name of the dictionary because, oh, you can see here, it has a special color. because dict is used for dictionary creation. This is a function, and if you redefine it, it will not work in the future. But dictionary is a legit name for the dictionary. So we have dictionary, and using double asterisk, we can unpack dictionary. Boom, 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 boom. Must Google the syntax, or it worked just inside the function. Okay, let's see what will be if we unpack it inside the function. Let's assume that we have function foo with arguments, keyword arguments, and inside it, okay, foo takes 0 positional arguments, but 1 was given. Okay, let's go to the Python org documentation. For me, it's the best way to understand what's going on with some hard places. Documentation, we can use Python 3 tutorial, I think, because here we have a function defining. Yes, we have. And default, we already talked about default function arguments, keyword arguments here. So I want you to read with me. Functions can also be called using keyword arguments in the form keyword equal value. Okay. So it's just a named arguments. State as diff, action wom, type Norwegian blue. This is a keyword arguments. So they have name and they have a value. So what we called named arguments with a value, they called keyword arguments. And here we print action and voltage. So we use arguments names to send their values inside the print function. Okay. And how we can unpack them? Yes, here. So double asterisk and keywords here, not keyargs, keywords they use. So it use after positional arguments. So we have some positional arguments, and after then we can use keyword arguments. Okay, try to imitate that. So let it be, where is my function? Function here. Positional argument X, and after that keyword arguments. And I want to use one. No, it's not working. We can use like this. Okay. We can explicitly use this. A equal 1 B equal 2, C equal 3. And here it will be 1, 2, and 3. So I think this is an additional information for function definition. The main things that we must remember is that we have a special word def for start functional definition. After that, we have function name that must be written in the standard way using PEP8. After that, we have describing of all arguments, semicolon, and with a new line, the body of function with return or without. So this function return none. So we can run it and print the value. It will be run. It must be not none object. Yes, it's none. The same thing is if we have return here. This is the same as none. And the stupid way to do it is return none, because it's the tautology. It will return the same none. So all this three notation is the same. I have only 1 minute. I want to show you that we have another notations called annotation of the function. For example, we can use two symbols with like error. This is minus, this is more symbol, and we can use this annotation to show what type this function will return. So in this example, it will return, for example, int type. You can think about this notation. So it's called, once again, annotation. You can think about annotation as a command that will used by another programmers to understand what type will be returned in the function. And it is not mandatory in Python. Without specific methods, it's not mandatory. And if function will return anything else, not int, it will be work well. So this is just an agreement between programmers to use annotations. I think I will describe annotations on the next lesson because time is over. Please ask your question if you have. I think we will have another lesson with function because it's not all. I have a lot to say about them. Guys, questions? Okay. I think something was clear from this lesson, and I will prepare the next module for you. I think that it's pretty cool if you will use the function calls, because many of you write your programs in imperative style without any functions. But please try to format your code to use dry paradigm. So enclose your code blocks inside functions and use them, because when you will write large programs, when you will write your computational pipelines for the research, function will be very helpful. For example, here in the Jupyter notebooks, you can use one chunk for one function, and this is beautiful to understand where you have your code blocks. Okay, I think that's all. Goodbye, guys.
Thank you. Goodbye.
Thank you.
Bye bye. Bye bye.
Thank you. Bye.